All right, 1.2 functions and graphs. So values of one variable often depend on another. We call it a function. It's kind of special. It's not just a relation where two numbers are in charts and we find a way to relate the two of them. A function, as a rule, assigns a unique element from a range to a domain. So the classic is range, domain. All right, so this gets real confusing real quick for a lot of people, but don't worry about it. Just if when you graph it, you can draw a vertical line through it and only hit one spot, you're good to go. And here's what's going on. Let's imagine we had a weather predictor. Said, hey, today is the 125th day of the year. We expect the temperature today to be 78 degrees. That's great. Let's turn that around. Let's say, hey, today the high is 78 degrees. What day is it? And if you don't know, January is at the bottom, and then you get up to June, and then you, I'm doing this backwards, and then you get to July, I should say, and then it comes back down till December, January. All right, so let's say 78 degrees was here. And you'd say, well, it hits twice. And I've drawn the graph the wrong way. I should have done it the other way. I should have said, well, the value we're putting in is down here. So the graph would actually be like this, and 78 degrees would be here. And it hits twice. Well, that's no good. This is not a function. As a matter of fact, the top one is a function, even though horizontally hits twice, because vertically it only hits once. The purpose of mathematics is to model the world, so a function thing is kind of a big deal. We write a function like this, and now we can assume that it doesn't break this rule. And we say it f of x. We don't say fx, we say f of x. So for example, what is the function that expresses the area of a circle? And more to the point, what is the variable? So that's kind of important because we're going to do a lot of calculus where there's no variable and people get lost. So the variable is r. I have a lot of trouble drawing decent r's. And the area with respect to r is pi r squared. So the pi is a constant. Just be aware of that. Now domain is x and range is y. And you spent a lot of math talking about them. You do not need to worry much about it. So what is the domain and range for the circle function? This circle function up here. Boy, I lost myself for a second there. Well, we can put in anything for radius, although radius is always going to be positive, I would imagine. So for domain, I would say including 0 and going to infinity. And this is notation you need to get used to. And I would say the range would be the same thing. If I put in 0, I get out 0. And the bigger this number gets, the bigger this number gets. That's just domain and range. A lot of people get really hung up with that. Don't. It's not that big a deal. We're not going to have to do AP problems where we get into domain and range. I've never seen one, let's put it that way. So what's interval notation? Well, we have no equal here. So we write it as parentheses -3. We have an equal here. What a mess. So here we put a bracket. And that's interval notation. How else could we do it? Well, we could do this sort of thing. X such that -3 is less than x is less than or equal to 6. Never going to do that. Or we could do a number line. And we could either squiggle in between here, or we could do one of these weird things. But like I said, we're never going to do that. we're going to use this. Notice up here, infinity gets a curvy bracket, which makes no sense, but you can never actually get to infinity. I guess it does. No, I don't like that either. So you got to know these graphs. You got to know them ice cold. You can't be busting out your calculator to know them. All right. Let's make a bunch of coordinate planes here. All right. 1 over x, I believe, is up here and over here. So domain is all reals except x can't equal 0 because we can't put 0 on the bottom. All right. What's the range? Very similar. All reals, y cannot equal 0. Hey, I thought you said we're going to do interval notation. All right, fine, whatever you want. Negative infinity to 0, not included. Union 0 to infinity. Same deal here. Negative infinity to 0, not including 0 to infinity. This is why people hate math, and no, we're never going to do that again. So don't sweat it. Square root of x, like this little up line. Domain is 0 to infinity. Range is 0 to infinity. Piece of cake. My bad, we can actually include 0 in there. You can't take square root of 0. You would get 0. Here, square root of 4 minus x squared. Now, this is something we're going to get a lot of coming forward. Now, we've only got the positive here. There's no negative here. Why does that matter? Well, you'll see. Square both sides. 4 minus x squared. Move the x squared over. Hey, that's a circle. Off we go. Well, no, we only have the positive half. So we're just going to go up here. Positive 2 to negative 2 goes as high as 2. Get used to this because that's a function. Hey, it works. If I made a whole circle, it's not a function. We got to cheat and use parametrics to define that. Another story coming to your math classroom soon. So this is going to go from negative 2 to 2 because I can put in negative 2 or 2 here. And the range is going to go from 0 to 2. And 1 equals x to the 2/3. You can put anything in here. This is a very specific one for calculus. A little trouble doing my curves to the left. So domain is everything. And the range is 0 to infinity. So a lot of people get real amped up about this. You don't have to worry about it. You don't have to worry about it. You need to know this graph. You don't have to worry about domain and range. I'm just giving you some examples. But if you do, just graph it and look at the graph. There's not much to talk about. So what's the definition of an even function? Well, this one always bothers me when I see math teachers do it. It means if I put a negative x or an x in, they're the same, whatever. It means it folds over in the x-axis. So this is supposed to be cosine. Because if I put in pi over 2, I get 0. If I put in negative pi over 2, I get 0. If I put in pi, I get negative 1. I put in negative pi, I get negative 1. So that's a good example. An odd function is where f of negative x equals negative f of x. Take a wild guess which one I'm going to graph now. Ooh, missed. So f of x equals sine of x. So if I put in pi, I should get out, pi over 2, I should get out 1. Negative pi over 2, I get out negative 1. So negative 1, negative 1. It has point symmetry. If I rotate 180 degrees, I get the same thing. How do we know if a function is even or odd by graphing it? That's what I just meant by symmetry. Fold over the x, the y-axis. Rotate 180 degrees about origin. What I mean by that is if I rotate it 180 degrees, it looks the same. It goes up to the right, down to the left. Goes up to the right, down to the left. What I mean by fold over is if I was to take the page and fold it over, it would land right on top of itself. It's pretty handy. I use that in Calc. I use that in a lot of math. So yeah, good to know. Term following functions are odd, even, or neither. Well, I am not going to get into it. I'm just going to say, yeah, even. And by the way, that's where even comes from with the even exponent. Not always. It's not a giveaway, but yeah. Even. This is also even. Not sure. Graph it. Yep, even. Hey, we didn't graph this one. Okay, fine. Don't get all upset with me. Yeah, you're right. Fold over, it's even. What about X? Spin the page. Yep, odd. What about X plus 1? Spin the page. Doesn't look the same. Doesn't fold over. Neither. And this is just the thing. They'll ask a question on the AP. Pretty rare, but I have seen it. Hey, you have an odd function and blah, 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 blah. And you have to think, okay, well, that means what's going on in the other quadrant. So how do we graph a piecewise function? So x is less than 0, we get negative x. Y equals negative x. That's y equals x, negative x. And it's less than 0, so we put a big honking dot here and go up there. Okay, and then x squared from 0 to 1. So plug in 1, I get out 1. It's going to do a little dot, and we'll connect to it, and a little dot. And then 1, x is greater than 1. Off we go. What is the domain? So that's why we have to look at the graph. Domain, I can put anything in and it works. So negative infinity to infinity. And the range, 0 and up, because it keeps going up that way. All right, here's another one. Graph this, then write as a piecewise function. And also find domain and range. It's kind of a pain in the butt, isn't it? So I happen to know that we're going to go up 3, and then we're going to shift. We should shift left with negative, but inside parentheses always goes the other way. So we're going to get one of these. By the way, this is something you might actually have to do, but never on an AP test. I have to do it in my classroom. And it's not a bad idea to take this and say, well, let's write it as piecewise. The domain, by the way, goes everything. And the range goes 3 and up. So we would write that when x is less than 2, it's negative x plus 5. And they use a comma. I like a semicolon. X is less than 2. Now I could say less than or equal to 2, and then get rid of it on the next one, but it doesn't really matter. This comes down, hits at 1. This goes up, hits at 5. By the way, you can plug that in and check. So what's going on at 2? Plug in 2. Negative 2 plus 5 is 3. Plug in 2, 3. Okay, it looks like it works. X plus 1. Down hits at 1. So the slope is negative x, down to the right 1. Y-intercept is 5 just by counting over and up. Same thing here, slope is x, and then down, over, it's at 1. So this one I decided to make greater than or equal. I could switch these equals as long as I'm not doing it for both, in which case it would not be a function, and you'd be accused of breaking math laws and have to go to math jail. It's a horrible place. So what's composite? Composite function. I hate it when I say composite. Function tucked in another function, and we only need this because when we do derivatives with a chain rule, you've got to be aware that there's 2 functions. So here's f, here's g. F of g means take f and write it down without a variable. So I leave a big blank. And I take g and I put it in there, and that's f of g of x. I could write it again, but you know me, I'm lazy. What is f dot g? Same thing. What is g of f of 2? Now it's backwards, so we can do this piece at a time instead of trying to get confused. Plug in 2. 2 minus 7 is 5, so f of 2 equals negative 5, pardon me. And then g of f of 2 is g of negative 5, which is 25. Hey, look at that, I got it right. All right, a lot of composite functions in calculus. I do not teach it as composite functions because I think that's just kind of dumbing it down to make it easier, and I don't think it makes it easier. So that's it. Happy mathing.